Hello everybody, and welcome to my video on graphing polynomials. So when one wants to graph a polynomial, again, using calculus, let me be very clear. I'm going to utilize calculus to get a complete picture of this. The great thing about the TI calculator, you can plug that into your TI calculator and get a quick picture of what we're going to do. Everything on this board should match up to that analysis. So the function is 3x cubed minus 3x squared. I want to have a graph of this polynomial. Well, the graph of this polynomial will be done in 3 steps. I'm going to rip apart the derivative. So the derivative of this expression is 9x squared minus 6x. Please check out my derivative rules if you are having trouble with the derivative. So there's my derivative, 9x squared minus 6x. I'm going to analyze the derivative. That's my first thing. To analyze it means I'm actually going to take a look at the derivative when it's equal to 0, because that's where you find max or mins, all right, is when the derivative is equal to 0. So we're going to set this equation equal to 0. All right, so we have the derivative equal to 0. How do we solve this? There's a bunch of topics: quadratic equation, factoring. I got a trick from algebra. If they both have an x in common, I can factor it out. So I'm going to factor out an x. So my good old factoring skills leaves me with this. Don't forget your x now. People often factor the x and forget it. Don't do that here. We need that x. Because what we're going to do is set each of these to 0 now. And upon setting each of these to 0, I can solve them. The x equals 0. I didn't want to forget that. That's a very important point to me. And the other one, add the 6, divide the 9. That's what I get, 6 over 9, which, yes, I know can be reduced to 2/3. We'll leave it as 6/9 for now. So those are what we call the critical points. So as you're working and somebody says, what are your critical points? There you go. You got 2 critical points. What are they? Are they a max? Are they a min? Are they neither? I don't know yet. You can't just say, aha, that's my max. Aha, that's my min. I don't know. So what do I like to do? I like to test them. And the way we test them is called the first derivative chart. You'll see this a bunch of time on my homework, is the first derivative chart. What we do is we take any points you found down here, put them in order, 0 and 6/9. And allow me to write that as 2/3 because it is annoying me. 6/9 is 2/3. So I've cut my universe, my number line, up into 3 sections. Numbers prior to 0. So I want to pick a number prior to 0, like -1. I want to pick a number between 0 and 2/3. Oh, there isn't one. Yeah, there is. They're called decimals. For example, 0.5 fits nicely in there. I need a number after 2/3. Now, don't be cute. Don't try to get something close. There's not limits. Pick far enough around. So pick number 13. I don't care, as long as it's past 2/3. These 3 green numbers are representative numbers. You can pick whatever numbers you want. Now, what we're doing is the first derivative test in many respects. These 2 numbers are questions. Are they maxes? Are they mins? Are they neither? What are they? I'm going to analyze them utilizing the green points. I'm going to take the green points and plug them into the derivative. That's what I do. Green points into the derivative. All right, that's why I need the derivative. So I plug in -1, and I got to be careful with my algebra. When you plug in -1, I don't care what number you get, but I do know we're getting a positive number out. So I plug in and I get out a positive. That's important to me. Anyway, flashcard. Derivative positive means function is increasing. I know my function is increasing. So I now know derivative is positive, function is increasing. This graph is going uphill prior to 0. So 0 is potentially a max. To get to a max, you got to increase up. So it's potentially a max. All right, 1/2. Plug it in. Be careful. 1/2 squared is a quarter, so that's 9/4 minus 3. That looks like a negative to me. So we get a negative there. And so that means we are decreasing. Because we got a flashcard. If the derivative is negative, we are decreasing as a function. Just vocab, guys. Increasing, derivative is positive. Decreasing, derivative is negative. Just got to keep flashcarding those. Let's plug in 13. Well, 13 squared is huge. We're back to positive again. And so we're back to increasing. So if I look at the graph of this on my TI, I should always have the graph of that TI handy, right? Boom, got the TI handy. Graph it. I should see uphill, downhill, uphill. I should see up, down, up. If I don't see that, either I graphed wrong or something's wrong here. It's good to have a visual check of my work. All right, So what do I now know? Well, look at this. I go from increasing to decreasing. I go from derivative positive to derivative negative at 0. That makes 0 a maximum. So there's my maximum. My maximum is at 0. And of course, when I plug in 0, I get 0, 0. So the point that's the maximum is 0, 0. Flip side, 2/3. At 2/3, it is a minimum because I go down then up, right? I go from decreasing to increasing. A minimum is when the derivative is 0 and the derivative goes from decreasing to increasing. That is, the derivative goes from negative to positive. So this is my minimum. This is a great example because it's got maxes and mins. Oh my. So gotta pause now. That's enough. What we gotta do is understand what the derivative gives me. Gives me maximums, check. Gives me minimums, check. But the derivative also tells when am I increasing. Here we go. Prior to 0 is when I'm increasing. When am I increasing? After 2/3 is when I'm increasing. Please read your questions carefully and answer them. What am I decreasing? I'm decreasing between 0 and 2/3. And you do a little interval there. 0 to 2/3 is when I'm decreasing. For this, you would go 2/3 to infinity. For this, you go negative infinity to 0. Those would be your intervals of increasing, decreasing, increasing. A very thorough analysis of the derivative. Nice. That's what I call my stage 1. My stage 1 is always to take the derivative and rip it apart. I always do this. The great thing about this, if somebody wants me to maximize or minimize, this exact same steps. I never change my steps. You want me to find a max or min? I did it. Maximum, minimum. Done. No extra work. Now, I want to do a little bit more in the graphing though. I'm going to keep this chart. This chart is awesome. And I got rid of the derivative. Good news is it wasn't that hard. If it was hard, I'd be crying right now. But the derivative is 9x squared minus 6x. The second derivative. Let's go what I call stage 2. Dun 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 dun. Stage 2. What we have is the second derivative. So the first derivative, the analysis is done. All right, it's all boxed off. Looks pretty, looks sweet. I'll look at that in a second. That's the first derivative information. I want to know now what the second derivative will give me. What kind of information graphically will I get from the second derivative? Well, the answer is very similar. And honestly, the analysis that I do on this board, exactly the same steps. I'm going to take the second derivative equal to 0. I'm going to do the algebra first. And I set that equal to 0. I add the 6, divide the 18, and I get 6 over 18. So I take the second derivative equal to 0, add the 6, divide the 18, 6 18ths, 1/3. I find that number. What is that number? Well, that's a critical point for the second derivative. What could it potentially be? It's my point of inflection. Potentially. I have to do a chart to guarantee it. I always do the charts to guarantee it, because just in case your professor decides to mess with you. So this is what I call the second derivative chart. The only thing I put on this chart is 1/3 because it's part of the second derivative. What I'm going to do now is pick points again. I'm going to pick a point before 1/3, like 0, and pick a point after 1/3, like 1. Again, the red numbers are random. Green numbers are random. I'm going to plug them into the second derivative, and they're going to tell me about the sign. Plug 0 into the second derivative, you get a negative. Plug 1 into the second derivative, you get a positive. I guarantee if you plug any number past 1/3 in the second derivative, it will be positive. All right? And that's because, every now and then I like to slow down. This is the only point where the second derivative is 0, which means all other points have to be negatives or positives, and they can't switch in between. Here comes flashcard. I love this example. You really should beat this example up on a piece of paper, write down all of the definitions, because it's all in here. Negative second derivative. That means we have concave down. That means we're bending down. That's what it means. It means the bends are down. The slopes are bending down. Second derivative is positive, means we're happy. We're bending up. We're concave up. If the second derivative is positive, we're concave up. If the second derivative is negative, we're concave down. That means this guy is a POI, a point of inflection. All right? We have a point we have a point of inflection whenever the sign changes. Please understand, I don't care if it goes positive to negative or negative to positive. If the sign changes, you have an inflection point, a point of inflection. So this is a point of inflection. And what I have now is really a really nice, sweet analysis of my graph. Utilizing these 3 points, I can get a really detailed graph. These honestly are the only points I care about in my graph. I'm lying. There are a couple other points that are important too, but overall, these are the most important. Think about it. Maximum profit, minimum cost, the point of inflection, the point at which your rates change from decreasing to increasing. That's huge in business. To finish this thing off, usually they want a quick sketch. That's why I always have a 3-step process. Step 1, analyze the derivative. Step 2, the second derivative. Last but not least, a quick sketch. And it doesn't have to be awesome. We all can't be awesome like me. Wink, 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 wink. So we have a graph. And we have 0. By the way, when you plug in 0, you get 0. So I can put the point there. Don't just put the point random, people. Plug 0 into the function, you get 0. Then we have 1/3, and then we have 2/3. So what we have here, and now what are the values? Well, I have to plug in 1/3 into here and get a value. I'd have to plug 2/3 in to get a value. I'm just going to make a leap of faith about this so I can kind of give a quick sketch. Since this is a maximum, I know the graph. That's why it's a sketch. I know the graph is coming up and doing a maximum here. And somewhere in here, the point of inflection, so that value must be negative. When I plug in 1/3 into here, I must be getting a negative one value. After a maximum, right, it comes downhill, right? Positive to negative, right? Increasing, decreasing. Somewhere right in between 0 and 2/3, there is a flip point where it goes from concave down to concave up. My story must match, and there must be a minimum that this thing flips back and goes around to. And what we have here is a beautiful graph of my function. I have the concave down, just like this says. I have the concave up, just like this says. I have my 1/3 highlighted as the point where everything changes from concavity's point of view. I have my minimum. Look at that. There's clearly a minimum there. Not an absolute, because that goes down forever, but that is a minimum nonetheless. There is another point out here you could find that might be of interest. The 0 point, right? There is one other point. I'm going to leave that to you to find the x-intercept, if you'd like. That'd be a nice point to graph, especially when we're talking about profit. If this is my profit function, this is not looking good for my company, but we're finally turning it around. We finally bottom out. Finally, we get control of our costs, and our revenues start creeping up to break even, and then we finally post positive. So that point is important to me, that break-even point in mathematics. Cool. Thank you guys for watching this video. I hope you stick around for others.